Good afternoon all. I'm looking through an old collection of, well, voltmeters and ammeters, these little LED digital ones. And in fact, there's one in here which I think is slightly different. I think this one, it's got a little button there and it says electrical parameter tester. That one I think is OLED, but the rest are all LED. In fact, I'm intrigued now. I want to see if this is OLED. But the problem with these things is I can never remember which wires go where, and this one I've actually got the data sheet in there with it, but I'm just going to sort of have a stab at it. The fat wires have got to be the ammeter, so the thin wires have got to be power. I've tied a knot in the negative there for some reason, I'm not sure why, but let's go for red and black on a 9-volt battery. These things typically have a regulator which can take up to 30 volts normally, and down to about, well, something above 5 so that we can get 5 volts for the CPU. Some of them are 3.3. Let's just stick that on. Yeah, that works. Black and red, and that is definitely OLED. Volts, amps, watt hours, amp hours, temperature, watts and time. That's quite nice, that one, but I'm not going to use that one. What I want is something to replace this. This is a voltmeter, and it doesn't need to be this accurate. Oh, my battery's going flat. The battery on the phone, that is. Well, here's a handy power bank, so I've plugged the phone into that for the moment. Yeah, I want to replace this voltmeter here, and I've got an ammeter sitting here as well, which I'll switch on, because I quite like to see how much current is actually coming into this battery. So this current is coming from my solar power wall. Oh, I suppose you want to see my solar power wall now. And it tells me the current coming in from there. Well, of course, the sun's out, so we've got a reasonable amount. And yes, my lights are on. Now, they're up here. This is the light switch for the cool white LEDs underneath these shells. So these are the cool white LEDs. Let's have a look at those. Those are on. And there's another set over there, and that's where I'm actually working. So that's drawing some power from that lead acid battery, 1.85 amps, 22 watts. So this ammeter tells me what's coming out of the battery. What I want is an ammeter telling me what's going in, and that's going in. So I want a combined voltmeter and ammeter showing me voltage of the battery. Now, yes, I realise that I've got a voltmeter up there, but it's quite interesting seeing the difference between the two, because of course that's the volt drop on this cable. So this one says 12.5. This one up here says 12.3, because of course there's 1.85 amps in this piece of wire here. So anyway, I'm going to have a combined voltmeter and ammeter on top of this battery. I don't want to have my DVM here all the time, because I want to use it in my projects. So let's use something like this. This is clearly volts and amps, because there's a coil of wire there for the ammeter shunt, but this one only has one row of 7-segment LEDs. So is that volts or is it amps, or does it flick between the two? Now I've got some pre-made up PP3 wires here. This one actually sensibly has offset positive and negative, so I suppose I could see what this one does by plugging it in. I hope that these are all pos and neg the right way around. Yeah, there is actually a little plus and minus down in there. It's hard to see. So let's plug that into the PP3. Not much can go wrong with a PP3. And oh, that's got 4 decimal places, which is very nice. And I'm assuming it just measures amps. It must be an ammeter. So if we're to measure amps on this thing, we're going to need a load. I don't want anything too heavy because this battery won't take much. So I've got this little 12-volt bulb. That should be fine. Let's just make sure that works. Yeah, that's fine. So let's put power on. Now, I'm just wondering whether black and black are both ground. One way I could tell, I suppose, is to clip that on there and see if this lights up if I put this black one onto negative. And it does. So yes, that's fine. Black and black are both ground. So to get a current shown on here, I presume I need to... Now the black and red are going to be either side of this current shunt. So in fact, actually, you probably find this will light up if I put red on ground. Can't see what I'm doing because I have got no 3D when I look through my phone. And yeah, it does, because that's almost ground. It's just the other side of that piece of wire. If we're not interested in measuring current, we can treat that as a piece of wire, and red can be another ground. So to measure the current taken by this light bulb, I will connect the battery properly. Whoops. And now I need to somehow get current flowing from positive on here, which is that one. Let's bend these legs a little bit. That one on the battery, and then feed it back through the current return, which is this one. And that works if I can hold everything in place. And we do get a current reading, and it is 83.5 milliamps. I presume that's what that means. Good, so that's kind of roughly how these things work. Because when I look at these things, I always think, oh, I can never remember which connection's which. But you can kind of work it out logically. But I do want my LED meter on the battery to be not just amps, I want it to be volts as well. So let's put that one back in here. How did that go? I don't think that was connected actually. I think it just went in like that. Now I've got some others in here. Oh, that one's only got 3 digits and they're enormous. There are 2 in here. Ah, that one actually says volts on the top, amps on the bottom. Let's just power that one up, assuming that they've got a convention for pos and neg on these 2-pin JSTs. I hope they do. I can't imagine the small current available from this battery would kill this if it were the wrong way around. Right, okay, so that one lights up. We've got volts and amps. Once again, if we want to see amps, it's going to have to be from pos of the battery to the return pin on this connector. And this connector is one of these. And it's got yellow, red, and black. Once again, I think it's fairly safe to assume that black is just another ground. It's the high current ground. So this will go to battery negative. We then need to get some current. Right, now wait a minute. Oh, why is that switching off? Oh, I think it's because negative there is touching positive on the battery and shorting it out. So let's do positive on these fat wires. Yes, that's definitely the measure cable. Now this is interesting because the big fat red is the measurement cable, and that's counterintuitive. You'd think that would be a power cable. Well, in this instance it isn't. Power for the display is on this thin cable coming from my little PP3. The only reason this is fat presumably is because it's sort of on the same connector as the fat black and the fat yellow. Now how are we going to measure current going back through yellow? If I do that, that's going to short, because yellow and black are either side of the current shunt. So if I do that, I could measure current, but it'll also short out the battery. So that's not going to work. I'll have to do it from yellow through a load which doesn't short out the battery, but which draws a current. And there it is, and it's 90 milliamps. What was it on the other one? I can't remember now. Now there's one other display in here, which is this one, which is also volts and amps. It's got 2 rows of 4 digits, whereas this only has 2 rows of 3 digits. So what does this one look like? Let's power it up. Once again, assuming that they have a... Oh, no, that's not working. So have they changed the positive and negative on this one? Wow, that's quite naughty. If I try and plug this in the wrong way round, I can just about get these 2 exposed connections to touch the 2 pins. It's a bit naff, but I can just about do it. And it lights up, so this one has got the polarity the other way around on that connector. That's terrible. That shows the advantage of using a high resistance battery. Yeah, the digits here are a bit wasted actually. They're just used to show a V and an A, so you haven't got any more resolution on the ammeter on that one, so I won't bother using that one. So I think I'm going to use this one with a little V and an A actually printed on the cover there. So to measure the current coming in and charging this battery, it actually comes in on this twin core. This is a solid copper wire actually. So negative goes on to negative of the battery, positive just goes on to my ammeter here, and then the other side of that goes to the positive of the battery so that I can see current the right way around. Now I think if I'm to measure the current coming in and going into the battery, the black wire on my little meter will be there. I need this negative feed to go to the yellow wire, I think, so that I can measure a slightly more positive voltage on the yellow wire than the black wire, and we can therefore measure current. So I think I'm going to have to tap in here. This wire can go directly to battery positive. Now I said I was going to show you the power supply, the power station on the fence. I'll do that now. Let's do it in context. So there's the lead acid battery that powers the lights in the workshop. There's the big solar panel that charges the lithium power packs. Here are the 3 solar panels, and there are going to be 3 charge controllers into the 3 batteries which are behind those protective shields. They're just to keep the sun off the batteries. At the moment there's only 1 charge controller. It's merrily flickering its blue light. Oh, why can't we see that? We can see it now. So it's charging this big lead acid Trojan battery down here. Well, in the winter I'm going to need all the power I can get from these 3 solar panels. Currently I'm only using the middle one, but in the winter I'll have 3 charge controllers. Each solar panel will have a charge controller charging its respective battery, and then the batteries are actually connected together via these hung up loops of wire, one there and one there, not through a large high current interconnect, but just through a low current interconnect, and it just means that the voltage on the 3 batteries equalizes slowly, gradually over time. Then there's also this, as I say, single core twin copper wire running up behind this solar panel, and currently temporarily through a little knot in the side of the workshop, and that comes in here through that hole there, comes up and charges the lead acid battery. That's how this system works. So this is my chosen voltmeter and ammeter. Now I want to use these fat cables as a sort of rigid mounting. So this one will come around this side and be negative. This one is the measurement for positive, so that will come around and attach to the positive terminal of the battery, and that will mean that this meter will sit on top of the battery and won't move much because these are fairly rigid wires. The incoming supply from the power station on my fence, negative side of it will go to yellow, because as we know yellow and black are pretty much the same potential. They're linked through the current shunt, but the slightly higher voltage here will show up on here as a current. And then I don't think I need the thin black because the thick black is connected to the same ground point, but I will need the thin red, which will double up with the fat red on the battery positive terminal, and that will actually supply power to the meter. So I'm going to go and do some soldering, get some terminals on here. This one I think I might just have a press fit connector temporarily, but I'll put ring terminals on the red and black so that this thing can sit on top of my battery. This thin red I'll probably put in the same ring terminal as the fat red. Let's go do some soldering. Or shall I do it out here? Maybe I will. So I'm going to use these 5mm forks to go on the battery. This pair of pliers just holds it nicely because there's actually a gap, so they sit nice and flat in there. and then I'll pull off the red bit, which I don't want, because what I really want is uninsulated, because I'm going to solder this and put heat shrink on it. But you can't get many of these in uninsulated, so now I just get them in red and just pull the sleeve off. It's easy enough and quick enough to do. I used to get the uninsulated ones from Rapid, but they've reduced their range a lot now. Right, I need helping hands to clamp these while I solder them, and some heat shrink. I'll go and get it. So that goes in there while I heat it up and put solder in it. Let's do that now. Oh no, this isn't switched on, so I'll have to wait for that to warm up. And I'll just show you something else I've brought out, which is this. This is the best power tool I think that Ryobi have ever made. This is an 18 volt heat gun. It's absolutely brilliant for heat shrinking without being tied to the mains. Okay, let's go. Bit of solder in there. Wait till it's taken. Fill it up. I didn't pre-prepare this, did I? Because I want to put, well, let's do the black. So let's put one of these pre-cut lengths of black heat shrink on there. That's a bit long actually. Let's cut that down. And there's a bit of blobby solder on there, but it should be alright. Okay, so I've got to heat this back up. Try and make a physical connection between the iron and the solder. It's always difficult. And in we go. And as soon as it locks, I'll slide that up so that it partially shrinks due to the heat that's remaining on there. And then I use the heat gun. This is really annoying. You have to press this. It's just a sliding spring-loaded catch which stops you pulling the trigger. So you have to kind of nudge it with your finger, and it's just a pain. I might remove it actually, and then heat shrink this. Fantastic! And all from 18 volts. Okay, let's do the one for the red. I'm also going to put one on the yellow, even though that's not going on a 5mm bolt. So flood it with solder, poke that in the hole, wait till it goes rigid and slide the heat shrink up, and then finish the job on the heat gun. And while this thing stays warm, it takes a few seconds less to actually heat shrink the heat shrink. Right, one more, and that's the yellow. Same process again. Get that to take. Feed some solder in. Oh, I've got the heat shrink on, yeah. Poke the yellow wire in. Wait for it to lock. Slide the heat shrink up, but don't faff about, otherwise it pre-shrinks and then you can't, like that, and then it won't now slide because the end got pre-shrunk. Annoying. Bit of poking and stretching and fiddling with pliers, and it's not beautiful, but it'll do. That gets very hot. You can see that glowing red hot in there. Fantastic tool, this one. Yeah, so the idea with the yellow one is I'm going to put the spade into this little press terminal like that. It's probably still hot actually, and then the incoming negative from my power wall will go there. That will then flow through yellow down to black to charge my battery, and we'll see the current on here. And of course I've messed this up because I put the red on and I didn't put with it the little thin red to supply power to the meter, so I'm going to have to strip that off, unsolder it and redo it. Let's put a bit of solder on my iron so I can just get this hot. Yeah, there we go. Draw that out. I'll just remove the blob. And now I can put the little thin red in with the fat red. Sorry about all this mess, incidentally. I was just spray foaming the roof of my workshop to seal it, because I think we've only got about 3 or 4 more days of summer left and then it's going to go cold, and I'm going to have to heat this workshop, and that's going to be interesting to see whether it retains heat. But more about that on my workshop shed building channel, link down in the description below. This is slightly challenging. I've got to get the thick and the thin wire into there. I've put a piece of heat shrink over them both, but they've got to go into the end of here, which is going to be slightly tricky, but that looks about right. A bit of solder hanging on the end of the iron. That's heated it up. Push them in. That looks pretty good. They both seem to be in there. Slide this one up. I won't worry about using residual heat. I can always heat that up again with the heat gun. But yeah, that's good. Both the wires, the thick and the thin, going into there. Heat gun. Makes very strange, sort of almost musical tones, that thing. I don't quite know what that's about. Right, that should be it. Now when I connect black and red to the battery terminals, this should power up. It should also show the voltage, courtesy of the thick red wire. That's the measuring wire. And then when I attach the feed from my solar power station to this yellow wire, the negative side of that feed, of course, it should then show the current flowing through yellow and down to black, which is of course battery negative. So first things first, I can take this ammeter, my DMM ammeter, out, because I don't really want to leave that in the shed overnight. So this is the negative coming from the power station. Now if these two short together, it's probably not the end of the world, because there's probably enough resistance in these wires that it would just slightly warm the wires. Not going to short them deliberately, but if they did short, I'm sure it wouldn't be a problem. That's the nut that goes on there. Right, now these are my wires going up to the lighting circuit. So I now want to take this meter off, which is just on crop clips, and that slides out, and attach my new meter using the thick wires as the sort of rigid mounts so that it will sit on the top. And this is going to take a bit of fiddling with. Also, I think I'm going to have to undo these. Oh, that's going to remove the overhead lighting, but oh, that's quite tight on there. Where's a spanner? Never particularly like adjustables because you have to adjust them every time you use them, but okay. That has removed the negative side. The lights go out, jolly good. So I'm going to reposition the outgoing cables on here. Should be able to grip that. No, I can't grip that. That's too tight. Where's my big pliers? Well, since I'm using pliers, I suppose I'm plying this off. Yeah, that's done it. Now I brought out a spanner. I guessed 8mm, was I right? Oh yes, very good. Let's reconnect the lighting circuit, and the lights come back on. There's quite a lot of sunlight in here as well, so you may or may not see the lights. Tighten these up. Now the reason there's a sort of spacer there is because this came out of my parallel array just outside my workshop, but so I'll just leave that configuration in place, because if I bring another battery up, I might actually bring some of the aluminium strips that parallel these up. So that's that. Right, this needs to go on here, so I'll bend that one. Let's put that behind there. The yellow can dangle down the back. Let's put the ground on first. That goes on there. And then I'm hoping the wires will just sort of settle and shape themselves so that this thing sits neatly on the top forevermore. Now of course this meter is going to draw a current permanently, but since this battery is always fed from the solar array, there should always be power in it, replenished. Now let's try that on 12 volts. Yeah, that works, and it says 12.4. So I've got to get the stressing of these cables right so that that meter sits in the right place. I suppose I could stick it down with a bit of blue tack for a while. That flickering is more to do with the camera's frame rate than anything. That looks pretty good, but it's not reading any current yet. Yeah, I don't really want that black wire floating about and touching positive, otherwise we're going to get a short through there, and it won't necessarily melt the black wire, it might damage something else, so I need to push that away somehow. Oh dear, lots of smoky smoke. And I can tell you what happened. The yellow wire, because it's sort of stressed similar to the red wire, came round and touched the red wire. Now we know that the yellow wire is the other side of the current shunt. So have I burnt out the current shunt? It is measuring some amps there, but that is going down. I don't really know. Yeah, what took the brunt of that mistake was the connector, not the shunt, because that's pretty big, and also apparently not the PCB, but the connections, I guess, are the highest resistance part, and they've gone all black, but it may still work. So just to see if this still works, to see whether it's still worth pursuing this, that's the positive feed from the solar power array. Now that's going to go on positive. I'll undo that and just wrap it around there for the moment. So I've turned the lights off. That says 12.7 volts, and if I connect my negative input current to the yellow wire, that's gone up. So yes, it is charging, it is running around and into the battery and lifting the battery voltage, but it's not measuring anything. So yes, that's a bit of a problem. So I guess what happened is there's supposed to be a very tiny voltage between yellow and black, and this thing amplifies that voltage and measures it and then displays it. I put a very big voltage, 12 volts, directly across the current shunt. That might have killed the input amplifier, whether it's an op-amp or just in the microcontroller, so that it is now no longer measuring. That I think will go up when I feed current into the battery. I think it was measuring about 0.5 amp, so yeah, that's lifting the battery voltage, but nothing on the display. I think it's bye-bye display. So this is a bit of a disaster, really. Let's take this off and have a bit of a look at it, actually. I suppose fiddling about with high current batteries, there is the potential for things to go very wrong. Yeah, so if we look in there, I'll try and get the camera to focus, actually. There is a lot of blackened stuff around the connector. Let's try and take that off. Oh, it's kind of welded itself on. That's not good. But it's come off. And yeah, there's some nasty charcoal around there. Well, I do have some more of these meters, so possibly it's time to just start all over again and not blow the other one up. This is really interesting. All the current, of course, went through the black and yellow wires. Now the red one is still flexible, but the black and yellow have gone all sort of stiff, because I guess they were heat treated when that vast current from this quite heavy duty lead acid battery went through these wires, and yeah, they stay where you put them. The red wire absolutely does not stay where you put it. Heat treated wires. And the moral of this story is that these sealed lead acid batteries pack a punch. No overhead lighting at the moment because, well, it runs on this. I'll put it back. So the question is, am I going to show this video? Do you want to see this video? If you really want to see it, I'll show it. But yeah, I've destroyed that voltmeter. Right, so I've got the red measure wire, which is the fat one, and the red power wire, which ironically is the thin one, together in one connector. I've had that sort of pushed into this hole for a while to kind of stress it. How did I do it? Yeah, like that, to stress it in the right direction, because my positive is on this side. The black wire is on this side. Now I wouldn't want this yellow wire to accidentally come around and touch the red wire and short the battery's full current through the shunt, would I? No. So what I'm going to do is put this pen over the yellow wire so that it can't accidentally short out. And another idea actually, which is a very good idea, is to completely remove the volt and ammeter module while I connect this to my battery. Yes, how tragic would it be if this all went up in smoke? Disaster that would be. So pos onto the pos side, neg right round here onto the neg side. There's a nut. Let's just put a nut on here. Can't really see what I'm doing, can you? Oh well. Like so. And now I can connect the voltmeter up. And if I connect the little power cable there, I should at least be able to read volts on it. Let's get the voltmeter. Here it is. Let's plug it in. Big fat cable first. That won't do anything, of course, because it doesn't have any power, which comes in through the little thin cable. Connect that up, and there we are, 12.5 volts. We just now need to get the current coming through so that I can get a current reading. So this is neg from my solar power wall. If I connect that to yellow, we should get some current coming through onto this battery. Why aren't we? Yes, this is really interesting. I'm sure some people will have realized this is a complete fake, but having the negative connected to the negative of the battery and putting my incoming current from the solar panels, in fact it's another remote battery, onto yellow, I'm not getting any current. But, and this is interesting because on this cable, it's the same meter and it still works, but the cable has yellow and black stressed in the same direction, so that's much less likely to be a disaster. If I put yellow onto the negative of the battery, it kind of works the same from the point of a voltage reading, and then put my incoming negative onto black, I then do get a current reading. So that's how it's going to have to be wired. The voltage reading actually might be slightly wrong there, but this is the only way that I'm going to get a current reading on that ammeter at the bottom and voltage and have it all work. So yes, I'm going to slightly change the connectors. I'm going to put a spade terminal on the yellow, and then I'm going to feed this negative from my remote battery into this black. It's the only way it's going to work. Now if you're a bit confused as to the timeline of this video, that's because I blew up the other cable, because it was stressed the other way on that cable, and yellow touched red, and it was on the battery, and the full current of the battery went through the current shunt, which is why it's looking a bit discoloured, but amazingly the meter survived. To see that disaster and the smoke that ensued, you'll have to go to my second channel, Julian's Shorts, where I put little short videos. There's a link in the description below. Yes, the point is the remote battery is at a higher voltage than this battery because it is charging this. So the only way the ammeter is going to read a positive current is to ground the ammeter to the remote battery and have this battery, which is a smaller voltage, on the yellow, so that the yellow is slightly higher in voltage than the black, and therefore we get a current reading. Now I'm not sure whether it's going to be terribly accurate, because you're not meant to ground this meter on the positive side of the current shunt. But it's good enough because it shows me a current which varies. I'm not worried if it's particularly inaccurate, and a voltage. The voltage looks fine actually. The current looks a bit high. If I switch on my shed lighting, of course it puts a load on this battery. That means the battery is going to draw more from the remote battery, and so the current reading goes up. So it all works. It's all fine. It's just a rather unconventional wiring arrangement. Strange. Cheerio.